Oh, hello. I didn't see you there. I was just about to talk about slope-intercept form. Glad you came to join me. So let's talk about slope-intercept form. Slope-intercept form is a form to write a linear equation. It is not slope. People hear slope-intercept form and they think, oh, it's y2 minus y1. No, 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 no. That's how to find the slope. Slope-intercept form is the way we are going to write the linear equation. And the generic form equals y equals mx plus b. Well, last time I talked a little bit about m, meaning slope, going back to René Descartes, the French mathematician, and the French word for slope or like hill was something with a m in it, but it's French, so whatever. Anyways, b is the y-intercept. That I have never heard a story on, nor really dug too deeply into why we use b for the y-intercept. Clearly not y because we already have a y there. And that's just x and y are any coordinate. If you want to know the x, this is dependent and independent. X is independent. Y depends on all this other stuff. So that's slope-intercept form. Now, things in slope-intercept form, I could have like y equals 5x plus 2. And if I'm just looking to identify the slope is 5, or I kind of wrote it smaller there. I was ready to write 5 over 1, but I'll write it separately. And then the y-intercept is 2. Now, why would you write it as 5 over 1? Because in a little bit, we're going to get to graphing. And when we are graphing, we do want to make sure that we know that it's rise over run. So we don't want to forget about that 1. If you're writing it in the equation, we don't write 5 over 1x. Okay? Slope could also be just something like y equals 1/3 x. You're thinking, well, there's no plus anything else there. Well, your slope is 1/3. Your y-intercept, some people will be like, well, there is no y-intercept. No, there is. We just didn't write it. It's 0. So your y-intercept there is 0. What about in the scenario where we have just y equals 5? Like, well, the slope is 5. No, remember the slope has to be next to x. And b is where your y-intercept is, the number by itself. So here, the slope is actually 0. We don't write 0x plus 5. That's not something we're going to put on there. We would just write the y-intercept as 5. So sometimes you'll see those scenarios too, where you just have y as 5. Now, what if there's undefined slope? That's a rare case where we have like x equals 2. That would mean at 2 on the x-coordinate or on the x-axis, you put a dot and draw a vertical line. There is no y-intercept. There is also no slope. That's why we say it's undefined slope. So here, you're going to say slope. This has no slope, and the y-intercept is not applicable. It doesn't exist for one like that. That's really not slope-intercept form, but it gives you that other, well, what about a vertical line? And so really, there are 3 things that we want to do this. We want to graph from there. So let's go back to this one first. Y equals 5x plus 2. And I'm going to draw a pretty crude graph. And for the graphs, all we're really looking for is, if you're sketching them on your own, can I see the y-intercept and can I see how far you counted over? So we start with, when you're graphing, I'm going to add it over here. So when we are graphing, you want to start with the y-intercept. The y-intercept is 2. So I go 1, 2. It's just on the axis. Now, my slope, going back to, again, I'm using this one, so I did the y-intercept, check. The slope is 5 over 1. So I'm going to go rise is 5. 1, 2, 3, 4, 5 over 1. So up 1, 2, 3, 4, 5, right 1. Now, say I'm running out of room here, which I am. You could always do the opposite. And 5 over 1 is the same as negative 5 over negative 1. 2 negatives make a positive. Well, if you're going the other way, I could look and say, all right, I'm going to go down 1, 2, 3, 4, 5, and to the left 1. Notice it'll still fall on that same line. So when we say start with the y-intercept, we started at 2, we went up 5, right 1. You could do that one more time if you had enough room. Okay. So then after that, we graphed using the slope and to get 2 more points. And I'm going to put there, that gives you 3 total points. The y-intercept and then 2 more points that is included in there that you have that you could use. Okay. So let's look at another example. Let's say we have y equals negative 1/3 x minus 4. So before I graph any of these, I always will write down the slope and the y-intercept. So I see what it is. I'm done. I don't need the equation then. None of this is helpful. Now I'm just looking and saying it was helpful. I know this y-intercept is negative 4. And then the slope is down 1, right 3. So I go down 1, right 3. And I do it one more time. Down 1, right 1, 2, 3. Okay, and I could sketch it out. Now, if you wanted, you could have done the opposite. What's the opposite of negative 1/3? Well, you just change where you put the negative. It doesn't matter if you go down 1, right 3, or up 1 and left 1, 2, 3. It'd be somewhere over there. But it would still be on that same line. Okay. Now, we could also go the other direction with this. What if I'm given a graph? I'm trying to make it very clear in the graph. It'll be much more clear on the trying to speak and think, much more clear on your Delta Math when you see it on there. On other things, if it's a test or quiz, it'll be clear. So from this point, let's say I had something over here, something over here. And again, it'll be very clear, so I'm trying to make it clear. The y-intercept is where I'd start here as well. What's the y-intercept? In this case, it's 3. Now, what's my slope? I'm just going to count it up. Up 1, 2, right 1. Check it again. Up 1, 2, right 1. So my slope has a rise of 2 and a run of 1 to the right. So now I'm going to rewrite it as an equation. Before we started as an equation, got the slope and y-intercept. Now we're going to go the other way. Here's the slope. Here's the y-intercept that I pulled from this graph, and I want the equation. Y equals, now I'm not going to put 2 over 1. That simplifies to 2. X, the slope always goes next to the x, plus 3. So we have y equals 2x plus 3. Okay? Let's do one more from there of taking a line and getting the graph, or vice versa, taking the graph of the line and getting the equation. So here y-intercept is down 1, 2, 3. And then I would count out and say, all right, up 1. Sorry, someone's spam calling me and I did not put it on mute. How embarrassing. Not really, it's okay. Up 1, right 2. So if I'm going up 1, right 2, that's my slope. Rise of 1, run of 2. Y-intercept of negative 3. And I would just jot down y equals 1/2 x minus 3. So the slope always goes next to the x. I'm going to write that generic y equals mx plus b. The y-intercept always sits by itself there. Okay? Now, what if I have something that's in a table and I'm going to put it in an equation? And I'm going to give an example. Instead of, I have my book next to me, but instead of writing it or showing you the book, I'll just do this example. So here's our table. 9, 7, 5, 3, 1, and negative 1. And if I want to make this now into an equation, well, the key thing is, where is the y-intercept? Right here. Why? Because the x value at the y-intercept is 0. I was going to write that as a point, which we did last quiz. This would be a point of 0, 3. I can't write 0, 3 in an equation, but that's the coordinate. So I'm looking for when is x 0. That's my y-intercept. So it's the same idea of saying, all right, the y-intercept is 5. I just couldn't look at a graph and point it out. And then I need to get a slope. Well, you can take now, we did slope before, take any 2 points. Doesn't matter if you take this and this. I'm going to take ones that are close to each other. So I'm going to go 3 minus 5 over 1 minus 0. I get negative 2 over 1, which simplifies to negative 2. So if I want to write that as an equation, the slope is negative 2, so I put an x next to it. The y-intercept is 5. So now we've written an equation in slope-intercept form from a table. Okay, so it's all about, you need the slope. It's in the name. We're trying not to be too tricky with math. We use nice, easy words that just mean what they mean. So slope, find it. Y-intercept, slope-intercept form. Those two things you'll either need to take out to graph it or vice versa. You'll need it from a table or from a graph. You'll need to find those two things so that you can write it as an equation. It's math magic. See you guys later.